Today we're going to look at lesson 2.3, the second part of it. Keep in mind our objectives were to graph linear equations, to find intercepts of lines, and to write equations of lines in slope-intercept form. So yesterday we talked about slope-intercept form, which was y equals mx plus b. Today we're going to look at converting equations into that form. So it's as if given a linear equation, we can always write it in slope-intercept form by solving for y. This lets you see the slope and y-intercept more easily. Makes it very easy to graph it. So looking at this first one, if we were trying to solve for y, my first step would be to subtract the 5x to the other side. And I am going to put the x term first, since we are looking for it to be in that mx plus b format. My next step would be to divide everything by -4. We end up with y equaling -5 divided by -4 would be positive 5/4 times x, and 16 divided by -4 would be -4. So in this case, we know that the slope is 5/4, and our y-intercept would be -4. For our second example, notice that we have some distributing that we need to do first. So let's go ahead and clean up the right side. We have 3x plus 3. And then it's almost in slope-intercept form. If we simply add the 2 over, we will get it into that slope-intercept form. So we have y equals 3x plus 5. So now my slope would be 3, and my y-intercept would be 5. When you have fractions, the easiest, quickest way to get rid of them is to multiply by your least common denominator. So if I'm looking at these, I have a 4 and a 2. My common denominator, I could get everything to have 4s. So I'm going to multiply this whole equation by a 4. 4 times -3/4 x, when I distribute it to this first term, just leaves me with a -3x. 4 times 1/2 y, half of 4 is 2, so we get 2y's. And 4 times the -1 is -4. And now it's similar to my first example where I'm trying to get y by itself. So I'm going to add the 3x to the other side. So I have 2y equals a 3x minus 4. And then I can divide everything by a 2, and I get y equals 3/2 x minus 2. -4 divided by 2 would be -2. So again, I can identify my slope and I can identify my y-intercept. So why is this important? Because to graph a linear function, we need to convert it to slope-intercept form. It's the easiest way. I will be showing you another option as we go through this chapter, especially for standard form equations, but very quick graphing when you know the slope and intercept. So let's go ahead. We just have to add the 2x to the other side to get this in slope-intercept form. In this case, we know our slope is 2 and our y-intercept is 1. So to graph it, we're going to start at the 1 on the y-axis, and we're going to rise 2 and run 1. So rise 2, run 1. My next dot would be there. Rise 2, run 1, rise 2, run 1. And now I can draw on my line. Okay, for our second example, solving for y, we're going to subtract the 4x. I have -7y equals -4x plus 14. And then I'm going to divide everything by -7. So I end up with y equals, again, a negative divided by a negative becomes positive 4/7 x. And 14 divided by -7 would be -2. So I can start with my y-intercept of -2. And I need to do a slope of 4/7. That means I'm going to rise 4 and run 7. Now typically we put several dots on here to get a nice line drawn. Since I'm out of graph paper on the right side, I can reverse both of those directions. I can go down 4 from my y-intercept and then back to the left 7. Okay, so a -4 and a -7 is the same as a positive 4 and a positive 7. Move. Gets me the same line. Okay? So now I can draw in my line, arrows on the ends. So having an equation in slope-intercept form really makes graphing quite easy. We can graph with a graphing calculator, and to graph lines on a calculator, it has to be in that y equals format. It's the only way it allows you to type them in. So go ahead and grab your calculators. We're just going to practice on one of these. Your first step is going to be to go to this key in the upper left corner that says stat plot or y equals. And then we're going to type in our equation. The key that we use for our variable looks like this. All right, I'm going to pull up my graphing calculator. When we hit stat plot or that y equals screen, we should see this kind of a window. And we're going to practice by typing in this equation, y equals negative 3x plus 7. All right, so I've hit my y equals key, and it's now waiting for me to type in my equation. We wanted a negative, and be careful on a graphing calculator, you must use this negative key, not the subtraction sign. We wanted negative 3 and then an x. Our xt theta n key is right here next to our alpha key. And then it was a plus 7 for our y-intercept. All right, and then we can graph it here. I usually do a zoom and choose 6. That's going to reset my window for me, so it's a nice negative 10 to 10 window in each direction. Often we have to change our window to graph, and this is an easy way to reset it back to that starting window. Okay, so notice it has a negative slope. We are crossing the y-axis at 7, and if we actually plotted some points on there, we would see a slope of negative 3. All right, the second thing that I wanted to go over today, besides graphing lines in slope-intercept form, is to look at x and y intercepts. We've been talking about the y-intercept, but we also have something called an x-intercept. It's where a graph crosses the x-axis. So to find it in an equation, we're going to plug 0 in for y. Okay, so when we are on the x-axis here, we have an x-coordinate of a number, but our y-coordinate is 0. When we want to find a y-intercept, we've been looking at those already. That is where we are on the y-axis, and it has the coordinates 0, comma something. In this case, a negative 2. Okay? So let's go ahead and look at a couple examples of this. To find our intercepts for our first picture, since it is already graphed, we can just look at it. We have a y-intercept here. It is down 1, 2, 3, 4, 5 spaces, so our y-intercept would have coordinates 0, negative 5. Our x-intercept, we're going to look at where we hit the x-axis, which is right here. That has coordinates negative 2, 0. So we typically say our x-intercept is at negative 2 and our y-intercept would be at negative 5. Our second example is not graphed. It is in slope-intercept form. So remember, this is our slope, this is our y-intercept. So right away we already know the answer to a y-intercept. It's 0, 5. Now, if you didn't remember that, y-intercept is the value we get when we plug a 0 in for x. So if we put a 0 in here, you would get that 5 out for an answer. Our x-intercept is the value we get when y is 0. So now I have to plug a 0 in for that, for my y-coordinate, and solve for x. Solving for x, I would subtract a 5 first. So I have negative 5 equals 3x, and then dividing out the 3, my x-intercept is going to be negative 5/3. All right, for our third example, again, we are trying to find x and y intercepts. Our x-intercept was the value for x when y is 0. So let's go ahead and put a 0 in for y. We have 2 times x minus 4 times 0 equals 12. but 4 times 0 is just 0. Subtracting 0 doesn't do anything. So we really get the equation 2x equals 12. And dividing by 2, we end up with x equals 6. So my x-intercept would be 6, 0. My y-intercept is the value for y when x is 0. So I'm going to put a 0 in for x. Again, 2 times 0 would be 0, so this simplifies to negative 4y equals 12. And when we divide by negative 4, we get y being negative 3. So my y-intercept would be 0, negative 3. For some equations, it's very fast to graph them if you can find both an x and a y-intercept. Our calculator doesn't graph that way, so that's why we went over how to put them into slope-intercept or y equals format. But finding the x and y-intercepts is another awesome way to graph a linear equation. All right, you guys are going to be doing a worksheet for today for 2.3b.